This is Dave Stallman. We're solving systems of equations using matrices. Step number one for this problem is to represent the system of equations using matrices. And so we're going to set up a coefficient matrix, which includes the numbers in front of the variables, 8, 1, 1, 4, a variable matrix, and a constant matrix. We're going to label this matrix A, X, and B. Now, what we want to do to solve this is divide by A, but you can't divide with matrices, so you have to multiply by the inverse instead. Now, let's verify, does the inverse matrix exist? And we determine that using the determinant, which is the A and the D values multiplied, and subtracting the B and the C values multiplied. So this looks like 32 minus 1 is 31. So this is non-zero. So we know that the inverse matrix exists. If we were to say this in complete sentences, we would say the determinant of A is non-zero, so we know that the inverse matrix A exists. All right, so next step, let's find the inverse matrix. It is 1 divided by the determinant, which is 31, and then we go back to the original A matrix and we switch the A and D values, and the B and C values, we change the signs. And so when you multiply each element in the matrix by the scalar fraction, we get 4 over 31, negative 1 over 31, negative 1 over 31, and 8 over 31. Okay, good. So now let's solve the matrix equation. So it's A inverse A X equals A inverse B. If we were to write this all out, the inverse matrix would be 4 over 31, negative 1 over 31, negative 1 over 31, and 8 over 31. And the A matrix is 8, 1, 1, 4, and the X matrix is XY, and the inverse matrix is 4 over 31, negative 1 over 31, negative 1 over 31, and 8 over 31. And the B matrix is 1737. So let's put these in our calculator, and then we can do some multiplying. Here we go. Second matrix, A is a 2 by 2, and it is 8, 1, 1, 4. Go into matrix, edit matrix number B, and that's a 2 rows, 1 column, 17 and 37. There we go. So let's do this first. A inverse times A. So matrix A inverse times matrix A. And it looks like we get 1, 0, 0, 1, which is the identity matrix. 1, 0, 0, 1. And so that's basically 1. And then we do matrix A inverse times matrix B, and we get 1, 9. So the solution to the problem is x equals 1, y equals 9.